as Sam mentioned, I'm the director of the MIT-IBM Watson AI Lab. It's a new industry academic collaboration really devoted to charting the future of AI. Okay, audience participation time. Who's heard of artificial intelligence? All right, awesome. Who has somebody in your company who's tasked with figuring out artificial intelligence? Okay, fantastic. So to echo Sam, we're all on the artificial intelligence train, right? Who feels comfortable they know what artificial intelligence really is? Okay, not a lot of hands. We got some hands, that's great. So who's heard of deep learning? All right, that's good, because deep learning is going to eat the world. So this is a Forbes article from 2015, and it's safe to say that machine learning and artificial intelligence are doing things that we thought were impossible just a little while ago. So here's an example of an image captioning task where you can take an image or any kind of media, increasingly videos, and you can produce natural language, beautiful captions of those things. So here, a man in a black shirt is playing a guitar, or a construction worker in an orange safety vest is working on a road. That's an AI that produced that caption. We have basically every game that humans were good at, that they were better than computers, we're basically done. Humans as game players are done. So, from Jeopardy to Go to poker, we even now have systems that we released earlier this year that can debate with humans and hold their own and perhaps even win against humans. So tremendous progress. Even things like art, creativity are starting to become the provenance of AI. And here are examples of art that was produced by AI systems. The problem, though, is that, so I'm a recovering academic. I was a professor at Harvard for many years. This is actually my first job, my first real job. Academics were very uncomfortable with the term AI. So if you're uncomfortable with AI, know that you're not alone. And in particular, we used to like to call it machine learning. And part of the feeling of that was that there's a sense in which there's many things that could be called intelligence, and what we have today, in many ways, doesn't live up to all of them. It's incredibly powerful. But here, when I joined IBM, IBM has a nice framework for thinking about that I just want to share with you, which is this idea of putting an adjective in front of AI and distinguishing what we have today as narrow AI. So it's incredibly powerful, and it's emerging capability. And then meanwhile, when people in the media talk about AI that's going to take over the world, or Skynet, or all these kinds of things, that's fine. Those are interesting philosophical discussions. And we would call those general AI. And if you look at the bottom of the slide, we have that listed as being perhaps 2050 and beyond. And when you ask scientists when something's going to happen and they tell you it's 2050 and beyond, that means we have no idea, but it's a long time from now, right? But what I really want to focus on today, and this is, I think, the thing that's relevant for all of our businesses, is this idea of broad AI. So what do we mean by each of these different kinds of AI? So narrow AI today is tremendously powerful, but it's fundamentally limited. So we have single task, single domain. So here we have an example of, if you have many pictures, like pictures of cats and pictures of dogs, or pictures of skin cancer lesions, this is the kind of thing that today's AI, if you have huge data, you can do quite well. In some cases, you can be superhuman in your accuracy and your speed. Meanwhile, on the other side, what we are calling general AI is this idea of broad autonomy systems that can decide what they want to do on their own. But where we think the real disruption is coming for your businesses in the next 5 years is this area that we call broad AI. So multitask, multi-domain, being able to leverage knowledge from one task and bring it to another. Multimodal, taking in information from lots of different sources, different kinds of sensors, different kinds of media, structured data, unstructured data. It's going to be distributed. It needs to be in the cloud. It also needs to be at the edge on our devices. And it needs to be explainable. You need to understand what it's doing. And really, that's where we see the opportunities lying. So I'm just going to walk you very briefly through these sort of 5 pillars of what we think are really the keys to launching this next revolution in broad AI. So to start, explainability. So I showed you this example of a system that was doing something remarkable. And in many instances in media, you'd like to be able to understand what was previously an opaque data source, an image or a video. And these are great captions. The problem is these systems don't always work. So here's another example of that very same system applied to some data. So this is a man riding a motorcycle on a beach. The system came up with the caption, an airplane is parked at the tarmac at an airport. And in this picture, the AI system captioned this as a group of people standing on top of a beach, which is true, technically speaking. So the problem here is that AI systems, as powerful as they are, oftentimes struggle to give us explanations. And particularly when they fail, it's not always clear why they fail. So one of the things we're working on in the MIT-IBM Watson AI lab is building new generations of explainable AI and debuggers for AI. So this is a big area where we're not only going to have to deploy AI systems, but we're going to have to be able to figure out why they work and why they don't work when they don't work. So here's an example of an interface created by a researcher at IBM Cambridge, where he's going through and he's debugging, he's figuring out a translation model where the translation has, an NLP system, a natural language processing system, has made a mistake, and he can walk through and unpack it. So we're increasingly going to see tooling and tools for explaining how AI works and being able to figure out why it's broken when it's broken. Security. Security is going to be another important area for the future of AI. So one problem that we have is that AI systems can, in many cases, be easily fooled. So a group at Carnegie Mellon University created these glasses where they took a state-of-the-art face recognition system that could identify the face of a person as well as humans could. But if you wear these very particularly carefully crafted glasses, you can trick the AI system into thinking you're somebody else. So if you wear the glasses on the left, then the system thinks you're Mila Jovovich. If you wear the glasses on the right, then it thinks you're Carson Daly. This is a mistake that no human would make, but it shows just how little we understand some of the fundamental abilities, how these systems, as amazing as they are, actually work. Here's another example that our own team at IBM Research produced, where we had an image captioning system, and the stop sign at the top, the caption the system produced was a red stop sign sitting on the side of the road. Again, this is remarkable that we have AIs that can do this at all in this era, but with just very subtle perturbations of the image. So if you look at those two images, I think we'd all agree they look identical to each other. And yet the image on the bottom has been very subtly manipulated, so the system instead produces the caption, a brown teddy bear laying on top of a bed, with great confidence. So in many ways, our AI systems, as we increasingly turn over decision-making ability to AI systems, we now have to deal with a new kind of hacking that's going to come with these systems. So we're building defenses now to usher in this next era of AI security. Another area is ethics. So as we turn over AI decision-making abilities, decision-making functions to AI, we need to have systems that are unbiased, that are fair, that make reasonable decisions, that can communicate with us in ethical terms. One example of this that's coming up again and again is preventing bias in AI. And this is a case where AI systems will often recapitulate biases that exist in our society. So even though the scientists who build these AI systems don't mean for the systems to be biased, oftentimes if the data they're trained on is biased, they'll then just turn around and give that bias back. So here's an example of loan approvals where an AI system trained on pre-existing loan approvals produced a bias against African Americans, so it's more likely to reject loans for African Americans. And we're working on methods to reshape that data to make the systems less biased. Now, these are being deployed in all kinds of different places, including deciding whether an inmate should get parole. So these are very serious issues, and bias creeps in all over every part of our world. Anytime you have data that you need to control and make sure that there are not demographic biases in them, this is going to be a huge area for AI going forward. And then another issue we have is that we need to learn more from small data. So everybody talks about big data, and many of us have big data, but at the same time, a lot of the problems we have in enterprise we're finding are in fact small data. And even when we have big data, oftentimes we lack big labels. So one of the things that AI systems need desperately is not just lots and lots of data, but lots and lots of carefully curated data. And in this case, even if you have lots of data, unless you've had humans carefully annotate all that data, you're not going to be able to get the real leverage out of these systems. And you can see this pretty easily in looking at what neural networks can do and what AI systems can do today. So this is a data set that was created as sort of a toy example just to illustrate just how far behind some of our AI systems are today. This data set's called Clever, and the way this works is you get a picture like this, and then you have to answer a very simple question like how many cubes behind the cylinder are large. And these are the kinds of things that we understand easily and transparently. We don't have to work or think hard to be able to do this. But even our most sophisticated AI methods based on deep learning and neural networks struggle to be able to answer these kinds of questions because there just isn't enough data to train all the different corner cases of this data. And what we're working on in the MIT lab together with Josh Tenenbaum is working on systems that bring together the power of neural networks and deep learning to look at images and understand the images and to understand natural language, but then fusing them with basic logic and symbolic reasoning to basically bring this forward. And we found that by creating these hybrid approaches, which we think are going to be really important going forward, we can get dramatic improvements. In fact, in this data set, we're able to completely solve this problem. So as we move towards genuine understanding of inputs like video and images and text, we're going to increasingly need to include more of that sort of cognitive logical structure in what we do. And then finally, infrastructure. So by some estimates, by the year 2040, if computing keeps on its current track, we'll exceed the power budget of the planet Earth. There won't be enough energy coming from the sun or stuff we can dig up out of the ground and burn to be able to keep up with our computing habit. And that's even if you leave aside Bitcoin. So one of the other things we're working on that we think is going to be really important in AI is building fundamentally new technologies that can operate perhaps 1,000 times less power. Whether we have it in the cloud or whether we have it in our edge devices, we're working on fundamental new physical methods for doing computing, in this case analog computing, which mimics how our brain works to be able to produce extremely low power, extremely capable AI. So we think this is a journey. AI is going to disrupt many different parts of our industries. And we think particularly as these blockers get knocked down, we're going to see tremendous disruptive potential. And I would encourage you all to treat this as a journey and come along with us as you understand and learn about AI. Thank you.